Recording in progress.
Ladies and gentlemen, please back on your seat because we're gonna start at 10 a.m. Ladies and gentlemen, our esteemed participants in this room and also our participants in online Zoom, welcome back again at the second topic of this lecture session. We're going to proceed to the second topic of today's lecture session with the topic applying reduced impact logging in harvesting system and quantifying carbon footprint of wood industry, which will be presented by Professor Dr. Masahiro Iwaoka from Tokyo University of Agriculture Technology, and also moderated by Ms. Rati Madhya Satyana, Bachelor of Forestry, Master of Science. Before we're gonna really proceed to the topic, allow me to give a brief introduction of our second speakers today. Professor Masahiro currently is the president of Forest Management Engineering in Japan, while our moderator, Ms. Rati, currently Ms. Rati is on her researching about strategies to improving occupational safety and health management system for forest worker in forest harvesting activities in Indonesia in 2022 until 2023. She had a lot of achievements. One of them is she already win about the poster presentation at IUFRO in 2013 about benefit sharing allocation in community collaborative forest management. Without further ado, we're going to really proceed to the second topic of this day. Ms. Rati, as our moderator, please proceed to the stage.
Okay, thank you. Good morning, everyone. How's today? Are you okay? Are you happy? Yes, the most important thing you should happy become the lecturer start. Okay. I will introduce the lecturers for today's topic about the applying reduced impact logging in harvesting system and quantifying the carbon footprint of the wood industry. The lecturer is Professor Masahiro Iwaoka from Tokyo University of Agriculture and Technology in Tokyo. He is also president of Forest Engineering Society in Japan. So his field is about the forest engineering, include the forest operation, forest utilization, forest route, forest machinery. So you can ask about that field to him. So now this is your time, Sensei.
Good morning, Sarmachian. So thank you for introducing me. And today I received the lecture theme applying reduced impact logging in harvesting system and quantifying the carbon footprint of the wood industry. So I'd like to talk to you about this topic about our. So my introduction is no need, already finished. So you can see I'm an old man, but this is first chance to lecture abroad. So I'm nervous. Okay. My research topics are develop and improve forestry machinery, evaluation and improvement of operation systems, calculation and evaluation of the environmental impact of forestry work, development and evaluation of woody biomass utilization systems, and evaluation and improvement of forestry labor. I'm sorry, I cannot show the mouse pointer here, so I cannot point the slides. One more, I must tell you bad news. My English is not so good. So, in the beginning, I was research on the mobile machinery, especially legged machine, especially this type semi-legged machines, very suitable for the steep slopes. However, it is not suitable for the loading. So this means that this type machine can be used as a harvester. However, it is not suitable to use for the forwarder. So I thought road-based systems are better than legged systems, legged machinery. And I became to think on total systems. Okay, here I'll start to talk about applying reduced impact logging in harvesting systems. This topic contains the conventional and new technologies. So what is the impact of logging systems? The movie I'm about to show you is typical ground-based systems in US.
At merchandising our wood. If we get into an area where there's mixed pulp and chip and salt, he'll separate it so we merchandise it in the best way.
So I said this is typical, but this is also relatively smaller one. And skidding along trees by a skidder disturbs soils on the ground. The disturbed soil is washed out by the rainfall and pollute water in the river. And this impact also affected the habitat of endangered species. So skidding along trees, harming to the standing trees around a skidding road. What causes impacts? Felling, skidding, and forwarding all over harvesting works causes impact to the environment. Furthermore, the preparing for the harvesting, construction of roads also causes impacts to the ground. So, felling, at first felling work. So even if the motor manual felling, like this slide, like this picture, causes impacts. Fell trees often damage residential trees in thinning operation. This is not problem in the clear cutting. So loud noise of chainsaws or other machinery affects organisms around. And felling operations sometimes affects surrounding endangered species. For example, bird trees killed them directly, and clear cut operation changes the environments of them. Not only felling, all of mechanized operation causes air pollution and large machinery impacts on soils. As I said before, the disturbed soils are washed away by rainfall and pollute the water in the river. Skidding operation causes heaviest impacts on soils, such as soil disturbance and compaction both. So these impacts cause soil erosion. The sediment that flows out pollutes the water quality, and skidding long trees often damage standing trees around the skid trails. And this large machinery causes air pollution also. Forwarding operation causes mainly soil compaction and relatively less soil disturbance than skidding. The soil compaction is caused by heavy contacted pressure of wheels or trucks. So travel route of forwarders must be restricted. However, in my opinion, forwarding is better than skidding in the point of view of environmental impacts. Next, I'd like to talk about our situation in Japan. This is our forest. Most of forests are on slopes, and many of the slopes are so steep. So ground-based vehicles cannot go through forests without trails. We use narrow trails in high density. Nowadays, such trails are popular in Japanese forestry industry. This picture shows the narrow trails. This is typical style. The road width is narrow and cutting height is lowest. Maybe have pointer. Okay. So we use cut to length like system in Japanese for using high density trails. Thank you. Thank you. We use CTL-like system using high density trays. In CTL, machines travel forestry freely in the forest. So, in a system, machines work only on the trails. In the CTL system, felling, delimbing, and backing are operated by one harvester. In our system, felling trees along the roads by a harvester, but other trees are felled by motor manual. And delimbing and backing are conducted by a harvester or a processor. And extraction is conducted by forwarder. This is same. So this system needs a motor manual felling and sometimes needs short extraction of felled trees to trails using small cable winch mounted on the harvester or processor. Or an independent grapple loader. These operations makes the system productivity lower. However, this system can be conducted on steep slope if only we could construct small trails. So this slide shows the narrow trails in high density. Former I said machines work on the trails, only on trails. Trail spacing must be sufficient to allow access to felled trees from the road. So, cut down the tree by motor manual, to the direction of the nearest trails. Mm. Mm. So the at least top of the tree can access from the machines on the trailers. Okay. So narrow trails will have less impact on the environment. Its width is 2.5. So its width is 2.5 to 3.5 or more. The narrowness is 2.5 because of the machine's width is about 2 meters. And cut height is maximum 2.0 meters, avoiding the broken of the slope. So this slide shows the small machines for narrow trails. Left two pictures show the small harvesters. Do you know harvesters? Okay. So the upper one is a typical size of Japanese harvester. It was is about 2.3 meters. So it needs 3 meters wide width of rows. And lower one is I think this is the smallest harvester in the world. Its width is only 2.0 meters. So it can work on the narrow roads. Its width is only 2.5 meters. So if the road width is wide, become wide, the to construct the roads much in the construction of roads, much soils must be moved to cut to bank. So narrow roads makes it smaller. So it is gentle for the environment and slopes. And right two slides show the Japanese further. It's Japan special. I think it's Japan special one. It uses rubber truck for driving. Not uses foils because the it can move soft ground by the rubber trucks, and not metal trucks. Rubber is more gentle to the soil, but trucks vehicles disturb the soils on the road face when the turning the direction. So if you need less impacts, I recommend cable system such as tower ladders. And here I introduce you the traditional cable system with the radio-controlled hydraulic winch and cable grapple. So this so this also this picture shows the tower ladders. Left two pictures show. Left two pictures shows the wonderful case and Sherpa U carriage. And the right two pictures shows the woodliner manufactured Conrad. And Wonder Falcon and Sherpa U are manufactured by Force Technique. Both manufacturers in Australian company. So Austria is also a mountainous country, but their slopes are so long and continuous. So the situation that is very suitable for toyers using long distance cables. However, in Japan, our topology is very complex, so slopes are not so long continued. It is difficult to use big towers. And more, the Japanese soils are so weak and fragile. So we cannot construct the road for the heavy machinery on top of the slopes. The carriage goes to
タワヤダの動力としては2トンあります。で、現在1本釣りなんですが、多分3本はこの時だったら3本はへっちゃらで、線路をこれるはず。タワヤダの2つ割り距離はですね、一番上の大きい線が主索が500メーター離れております。ということは、水平距離でいきますと、最大400メーター程度かなと。カチャーンと。
check on it.
ここで、半期の光りました。はい、斜め下の。距離が短い。
after
了解してこれから動画に入ります。
we start to the hooking point and stop at the programmed distance near the hooking point. So its operational efficiency is so good, and especially for the big trees. When one load become bigger, the productivity become higher. So towers carrying felled trees by lifting, whole lifting or lifting one end and grounded the other end. Less source disturbance than ground-based system. If the lifting one end and grounded the other end, it causes soil disturbance, but it is less than ground-based vehicle systems. However, the tower yards need wide and strong rows on the upper side of slopes. But it is difficult in Japan, as I say before. Okay, next, I will introduce you traditional cable system with remote controlled hydraulic yard and grappler carriage. This is manufactured by the Iwafuji Industrial Corporation, Japanese company. Now they developed this system and now still developing. So this system consists of Japanese special tiller system. We call it endless tiller system in Japanese. Remote controlled hydraulic winch and remote controlled cable grapple. So this picture shows, this figure shows the Japanese special tiller system. We call it the endless tiller system. In Japanese, endless tiller. So the system consists the standing skyline and one set of continuous line, which contains the main line and the whole back line. These continuous lines are fixed to the carriage. And lifting line, one end of lifting line is fixed to the ground. And another whole back line. So original tiller system have the whole back line like this type. And the main line is connected to the fall block. So that special point of the tiller system is lifting line is dropped from the carriage. Carriage has two sieves, and using these two sieves, lifting fall block on the lifting line drop from the carriage. And this So original tile system can uphill yarding, but this system uses the continuous line to move the carriage. So this can be used in the uphill yarding and the downhill yarding both. And furthermore, without the slope, the head tree and tail tree are both on top of mountain, and no without slopes. Skyline has no slopes, but it can move. So control the continuous line and lifting line and fallback line. And the operator can move the fall blocks to the any point he wants. So this system can gathering loss from not only lines but area. So this picture shows the radio controlled hydraulic winch. This winch has two drums and one driven sieve. This driven sieve moves in continuous line. And lower picture shows the control panel. And this system is controlled using CAN. And with the wireless receiver connected to the CAN. And the wireless camera can also connect. And this is the radio controlled cable grapple. So this grapple is driven by a hydraulic power, and the hydraulic power is activated when running. And also when running the controller grapple, power generator moves and electricity store in the lithium-ion battery. Control system move using electricity. So this figure shows the whole system. The operator control the hydraulic yarders and grapples. And by using his own site and cam site, camera is put on the 4-block grapple and see the ground around the grapple. So operator see the camera video, camera movie, and control the grapple to the logs. This is the introduction movie of the this system by the Iwafuji Industry Company. So grapple on the lifting line instead of 4 blocks. And this is the operator controlling the yarders and the grapple. And now lifting this tree. So this grapple can, this is a camera camera site from the grapple. And this is other machine processor. Oh, maybe it's not so good. So maybe a processor operator can control the yarding system. Okay. Stop this. Okay. Now move to qualifying the carbon footprint of the wood. I also explain about the life cycle assessment. At first, I'll explain about life cycle assessment. Life cycle assessment is the analysis of the impact of one object has on the world around it. product life cycle from the cradle to the grave is raw material extraction, manufacturing and processing, transportation, usage and retail, and waste disposal or recycle. So this slide shows the outline of life cycle assessment. Product life cycle is consists of raw material extraction, manufacturing and processing of parts, manufacturing and processing of products, distribution, usage and retail, disposal or recycling. And between each steps, there must be a transportation. And each step, and including transportation, needs energy, virgin resources, or recycled resources as an input. And all process outputs, air pollutions, water pollutants, solid waste, other waste, and recycled resources. So there are ISO standards on LCA as a part of ISO 14,000. ISO 40,000 is environment management. And about LCA, ISO 14,040 principles and framework. ISO 1441, goal and scope definition and inventory analysis. And ISO 14,042, life cycle impact assessment. And ISO 14,043, life cycle interpretation. This is based on the LCA framework. So this figure shows the framework for life cycle assessment. 3 steps: goal and scope definition, inventory analysis, and the impact assessment. On each steps, it needs interpretation. So useful analysis and assessment is important in the life cycle assessment, but interpretation is most important. Then the conductor must consider about the direct uses, such as product development and improvement, strategic planning, policy making, marketing, and others. So, what is the root of life cycle assessment? First, Coca-Cola Midwest Research Institute conduct assessment on environmental impacts of returnable glass bottles and aluminum cans. Returnable glass bottles does not need much new resources, but it needs much water to cleaning. And it has a heavy weight, so the fuel consumption on transportation is large. While aluminum cans are so light and needs low fuel consumption on transportation, but aluminum needs so much virgin or recycled resources and electric power to produce. So, which do you think which impact is low? Put right hand up if you think returnable glass bottles impact of returnable glass bottle is lower, while put your left hand up if you think aluminum cans impact of aluminum cans are lower. So 1, 2, 3. So most of you right. So impact of returnable glass bottles are lower than the aluminum cans. But nowadays, aluminum cans becomes so familiar to you. While so impact is low, but most big cause is aluminum cans is so light, right? So it's suitable for the mass transportation. So, so much Coca-Cola sold. They need aluminum cans for transportation. And for me, 1960 is a special year. Does anyone knows what happened in 1969 other than this? No, no, no. I was already born. So, are there someone who loves rock music? No, no. Yeah. You? Do you know 1969? So Woodstock Festival was held in 1969. After that, the rock music becomes commercialism. So I have no time, but I want to introduce one sample of the green LCA on the forest products. This study title is Greenhouse Gas Emissions from Roundwood Production in Japan. The purpose of this study is to produce tried to gate GHG emission, greenhouse gas emission data for determining the impact of roundwood production on climate change. So for tree species assessed Japanese Cryptomeria japonica, Hinoki cypress, Tamais paris obtusa, Japanese larch, Larix campari, Sakhalin fir, Abies saharinensis are assessed. And land use, its unit is no, this is a mistake. Square meter year is one of the indicator. So system boundary of this study is the whole forestry operation, seedling production to final felling and extract to the logs on the roadside. And in this study, we assess also indirect processes, forest road construction, production of miscellaneous articles, machine production and maintenance, transport of workers from company to workplace in the forest, and commuting the workers house from workers house to the office meeting place. So this figure shows the procedure for inventory analysis. Tree species yield for each prefecture, and the fuel consumption for each unit process, mechanization rate for each prefecture, and the LCA database. Using this data and calculate the roundwood greenhouse gas emissions for each tree species and prefecture. And using volume of roundwood production for each prefecture, and roundwood greenhouse gas emissions for each tree species are calculated. Then volume around the procedures produce tree species in Japan. Total round the greenhouse gas emission in Japan was calculated. So these four species are popular in Japan. And so total species, four species, about 80% of Japanese log production. But depend on the prefecture, the production species different. So we must calculate it on each 47 prefectures individually. So data are used shown here. It's not so important, but we concern about the yield. It is volume of rounded production per area. So is used to a local use table consumption systems named LAGS or Hokkaido Saharin for yield prediction system. And yield ratio in logging, it is rounded volume per stand tree volume. Japanese cedar, 85.9%. Hinoki cypress, 80.6%. Japanese larch, 77.0%. 77.0%. Sakhalin fir, 85.0%. So others on the prefecture data use the prefecture data, and the default minimum DBH subject to commercial thinning is 14 centimeters. Sensitivity analysis was conducted. So GHG emission, greenhouse gas emission from forest road construction is calculated with this formula using forest road density D, greenhouse gas emission from forest road construction per 1 meter EFRC, and yield of rounded YR. So greenhouse gas emission from transportation workers from meeting place to the workplace is calculated from this formula. This uses the forest management area, number of forest management agencies, and the number of workers required for rounded production, and greenhouse gas emission from worker transportation, and the yield of rounded. So, greenhouse gas emission factors I used to this. So fuel consumption for each process calculated as this slide, but the characters are too small and you cannot read, I think. But I'll show you the in the figure. This is also the this is also the activity data for production of 1 cubic meter over barks from each tree species. So these is here. Greenhouse gas emissions from production of 1 cubic meter over barks. Japanese cedar is relatively low emissions than other species. Difference is caused by the from seedling to non-commercial thinning, and transportation of workers, commuting, and miscellaneous articles. So this figure shows the relationship between the share of the advanced mechanized type and the greenhouse gas emissions on Japanese cedar. So this relationship shows the when the share of advanced type increase, greenhouse gas emissions also increase. But correlation coefficient is only 0.55. So land use area for producing 1 cubic meter of wax. So Japanese cedar is lowest. And then Sakhalin fir and large forests. Hinox cypress is largest. Hinox cypress needs largest area. It is over twice of Japanese cedar. This figure shows the sensitivity analysis results on the minimum usable tree size in dBH on differences of GHG emissions. So this figure shows there are no big differences between the different minimum usable tree sizes. So the minimum usable tree sizes in thinning is not affect on the GHG emissions. So this slide shows the sensitivity analysis result on the minimum. Sorry, it's not the minimum log size. Minimum tree size in dBH on land use. So this figure shows the when the minimum tree dBH become larger, the needed land use will become larger. And the effect is so different from the different between the species. So this slide shows the sensitivity analysis result on allocation between volume-based and market-based. So price of logs are different in the log diameter. Small one and too big one is cheaper, and the suitable usable one is expensive. So the volume-based allocation may not be suitable for the economical purpose. So we compared between volume-based allocation and the market value-based allocation. So the results of here that there are no significant differences here. So I think we can use the volume-based allocation to analyze the economical purpose. So okay, this is all. So from now, question time.
Okay, is there any question? Yes, please mention your name and from which country.
Hello, my name is Alex from University Malaysia Sabah, the Borneo part of Malaysia. So earlier in the first part of the presentation, you mentioned about reduced impact loggings and some of the machineries that we use for aiding in helping in reduce impact logging. And one of the techniques that I've ever learned before was using like helicopter logging, which I know that it gives a lot of advantage for like, especially on the, it doesn't really affect the land areas such as skidding or forwarding. But I want to know, in your opinion, about is the helicopter logging, like, helicopter logging really affects the environment in any other way, apart from like, the advantages are like, it doesn't really uses land for transportation and also reduces the transportation time from one place to another. But I want to know, is it largely being used, or and apart from that, is it like negatively impact in other ways to the environment? Thank you.
Yes, thank you for a good question. So, helicopter logging is gentle for the soils, as you say. But it needs much fuel to, to, to carry the same volume. So, especially in Japan, the cost is so expensive. It takes only flying without load. It is cost. So we sometimes use the helicopter logging in Japan, but all the very variable trees only. So and in your question, the bad impact is much fuel consumption. It produces the air pollution, much air pollution, and gathering of fuel is has much impact on the environment. And more, fossil fuels maybe finish near future, but it is for long time. When I was child, the fossil fuel is finished in a few 10 years, and now same. So, okay, other question.
Any other question? We still have time, 10 minutes more. Okay.
Hello, Prof. I'm Elisa from UMS. My question, just a simple question. Just wondering if the excavators use the harvester. Is it made in Japan or is it imported from other countries? Thank you.
It's a good question. So, usual size, the base machine with 2.3 meters are both manufactured in Japan and imported. But smallest one is, to tell the truth, imported.
Imported from
Yes.
which country?
From Germany. um, from Japan, but manufacturer is Sweden or Finland. So
Can I know,
the agriculture farmers uses the smallest one.
can I know the smallest discovered how much it costs, the smallest one?
Hmm?
How much it costs for one
No,
machinery?
no, it's so cheap. About 2000, 20 million Japanese yen, including excavator. So 20 million, 2,000 million rupiah. Yeah, 2,000 million rupiah,
Okay.
including basic excavator.
Okay.
Very cheap, but now it becomes a little expensive.
Thank you.
Hi, Doctor. I am Shakila from University Malaysia Sabah. Um, I have a question. Can you go back to the slides that have some plots just now? The one with gas emission, GHG emission with the different volume of three species. Because just now I think I have a glimpse of it, but I see the trend for Japanese cedar, the emission is the box plot is getting smaller as the volume higher. But compared to the other three species, the other three species, the higher the volume, the emission also is getting higher. So I wonder if is there like and is there why you focus more on Japanese cedar, and I wonder why the trend is like that, even though maybe there is no significant difference, but the trend is still there. So I just wondering why such happening.
So sorry, mic is not good. So please.
Okay.
So please use this microphone.
Okay. Hi. I am Shakila from University of Malaysia Sabah. Okay, so just now you show us some result about the gas emission with the different volume of trees and of different types of species. So I have like just a glimpse side of it, but I realize like the trend of the box plot for the Japanese cedar, the higher the volume, the lesser the gas emission is. But for the other species, the higher the volume, the higher the gas emission is. So I wonder, it's like why you plant more Japanese cedar in your country, and I just curious why such trend is happening. Like why there's although maybe there is no significant difference between the gas emission, I think, but yeah, that's why the trend is like that. It's like opposite. Only the Japanese cedar showing the an opposite trend from the other species. Thank you.
So えーっと、so as you say, Japanese cedar grow up faster than other species, but Japanese larch is similar. But so I think Japanese cedar has enough volume earlier, so impact is lower and more.
Um, No,
So it's the suitable for the environment, so each environment. So, oh, oh, most of Japan, except Hokkaido, we plant usually Japanese cedar or Hinoki cypress. Price of Hinoki cypress is much higher than Japanese cedar. So sometimes we select Hinoki cypress. And in Hokkaido, Japanese cedar cannot grow up. So most of in Hokkaido, we plant Saharin fir or Japanese larch. And more higher place, Japanese cedar also cannot grow up. So we plant Japanese larch. And nowadays, Japanese larch is price is very good because of the Russia stops export the logs 2006 maybe. So after that, we need Japanese larch for the veneer board, for product veneer board. So nowadays, its price is also good.
Okay, we have time 2 minutes more. Oh, okay.
Okay, Sensei. So I would like to ask, my name is Iman. I'm from UC Putra, Malaysia. So I would like to ask in NTHD, yeah, so we use tower header. So maybe in the operation, in the logging operation, when we want to, take the out, so we use the tower header. And then I want to ask, how many money should we allocate if we use tower header in the operation, in the logging operation? That's all.
Cost of machinery.
Yeah, I mean, the budget that we should put if we use tower header. I mean, like the operating costs if we use tower header.
So the operating cost per day becomes higher with the higher developed machines, but the productivity becomes higher, also higher with the high advanced machines. So the cost per volume is not so much different from the motor and advanced machinery. So at first we introduce machines to reduce cost, but machines are so expensive. So as a result, cost was not so much changed. But on the other hand, with using so expensive machine, but so usual forest owners or forest workers thinks I cannot use such an expensive machine, But if he bought the advanced machine, the cost is not so changed. So, but he can reduce the number of workers. No, decreasing the number of workers is also a problem. So, the purpose of introducing machines, one of purpose of introducing machines are reduce workers. So it's depend on the manager's opinion.
Manager opinion. Okay, the time is end. Thank you very much, Iwaoka Sensei. Today's lecturer is very useful knowledge. And from the committee, we have this one lesson from Prof Sensei. Yes. If you have another question, maybe you can write and send to the committee. Then the committee will give to Sensei before he left from Indonesia. Okay, Sensei, is there any last testimony or something?
Yeah, thank you for listening, and thank you for good questions.
Okay, give applause for Sensei. The last lecture, today we will take a picture together here. So please go.
Okay, thank you.
Welcome, Pak Dwiko.
Before that, we are really thank you so much for Professor Masahiro and also Rati. And please, ladies and gentlemen, rise from your seat to take picture here. And please, for Mr. Dwiko, please to the move forward here to take a picture together. Okay, thank you so much. That's all for our second topics of today. Ladies and gentlemen, please back to your seat. That's all for our second day's speak. After this, we're going to have a lunch and we'll be right back here at 5 p.m. Thank you so much for your enthusiasm because we're going to still proceed to the third topic and we will end it this today agenda. with a game session later. Thank you.
Recording stopped.
Yeah, can do.
Test. Oh, yeah.
Recording in progress.
Please, everyone, take your seat back because we're going to proceed to the third session. Good afternoon, ladies and gentlemen, our esteemed participants in this room and also our esteemed participant in the Zoom meeting. I would like to also welcome to our the third keynote speakers and our moderator. Commence our activity. Welcome back again to the third lecture session with the topic of implementation of intensive silviculture in Indonesia, an approach of 3 improvement practices. This topic which will be presented by Professor Dr. Ir Mohammad Na from Faculty of Forestry Universitas Gadjah Mada and also moderated by Dr. Nesti Pratiwi Romadini, Bachelor of Forestry. Before we really proceed to the presentation, allow me to read a brief introduction about Professor Naim. Professor Naim is one of the previous dean of Faculty of Forestry, UGM in 2004 and until 2008, and 2008 until 2012. Professor Naim also one of the experts of forest science, tree breeding, and silviculture. Professor Naim graduated with his doctorate of forest genetics and tree breeding from Tsukuba University Agriculture and Forestry, Japan. While our moderator here, Dr. Nesti, finished her doctoral in forest science in 2023 at the Faculty of Forestry, UGM. And currently, Dr. Nesti is a fresh lecturer of the silviculture course and focus at the silviculture and soil forest laboratory. One of her publications is about genetic diversity in seedling population of Dipterocarpus gracilis in Kecubung Ulo Lanang Nature Conservation Reserve, Indonesia. Without further ado, Dr. Nesti, as our moderator of the third session, the time is yours.
Okay, good afternoon, everyone. And welcome to next session, today's. And I'm so honored because I will be moderator for this session. My name is Nesti, and we have a guest lecturer, Professor Dr. Ir Mohammad Na, Master of Agriculture Science. And today's we will discuss about implementation of intensive silviculture, especially in the tree improvement approach. So we have 90 minutes and 60 minutes for the presentation and have 30 minutes for Q&A times in the F of presentation. So without any explanation, I think it will be good to start the presentation. So time and please welcoming in join Professor Dr. Ir Mohammad Na.
Thank you, Nesti-san. Good afternoon, everybody. First, I would like to welcome you to the University of Gadjah Mada and also welcome you to Yogyakarta City, the student city, and also cultural city. And I think everyone's very like to stay in Yogyakarta. I hope all of you also like that. Yeah. Even I already introduced by organizing committee, I would like to again to introduce myself. My name is Mohammad Naim. Muhammad is taken from the Prophet Muhammad, and Naim means happy, very happy. So in Arabic language. I'm not so young now because I already 70 years old, and maybe next year will be retired. And I think it's a good chance for me and also for you to meet us. My first study is tree improvement. Yeah, also breeding, because they are quite similar, meaning forest genetic, tree breeding, and tree improvement. It's more or less the same meaning, but different angle. So I entered this faculty in 1973. So I think maybe your parents, just postponed, yeah. But you still created by your parents. Today, this afternoon, I would like to discuss the implementation of intensive silviculture, especially in terms of tree improvement approach or tree improvement practices. This picture on the, and the viewer, this mentioned about some species that is very important in the forestry, Indonesian forestry, like natural forest, and then in the middle is pine plantation and also teak plantation. Actually, there are still some more important species, especially for timber estate plantation, but I not included those in this item. So what I want to do is to discuss about each of these species in terms of in terms of tree improvement approach. An introduction, I would like to mention about several problems, and now having faced by government of Indonesia, especially shortage of wood, of course, because of illegal logging and other reasons. Shortage of wood, yeah, because now the population of Indonesia is getting bigger and bigger, so of course need a lot of food. 3 is jobless people. 4 is a shortage of energy. So we also try to find out the proper wood for energy. And 5 is bad environmental condition. In terms of forest area in Indonesia, actually we still have a huge forest area. It consists of several functions. First, a conservation forest is about 25 million hectares, and protection forest 29, and then production forest is divided by permanent forest and also limited forest. So both of them is about 55 million hectares. And converted forest. Sometimes we also prepare for a piece of forest area becoming, things to be the other uses. About 12, but by 12 million hectares. So in total, about 135 million hectares is owned by Indonesia government. The number of forest area actually, especially in tropical rainforest, actually is becoming number 3. Number 1 is Brazil, yes, and second is Congo, yeah, in Africa, and third is Indonesia. The other is yes, a piece of small part of natural forest owned by several countries. So in terms of tree improvement, of course, we concern on productive forest. Productive forest, especially permanent forest. Ini tidak bisa. Ladies and gentlemen, this is the picture of natural forest, really very beautiful forest. And in Southeast Asia countries, maybe now only Indonesia still have very large tropical rainforest. This especially located in central Kalimantan. And in this forest, there are so many species we can find in this forest, especially related to the genus Dipterocarpus. And very famous here in Indonesia is called Meranti. Meranti is a species for timber, for wood construction. But if you are talking about the productivity of our natural forest, really the productivity is very, very slow. Recorded only 0.2 until 0.6 centimeter a year. When I was a student, my senior lecturer said to us, to the student, that mostly Meranti has increment diameter about 1 centimeter a year. But I think it's not true, because there's the increment diameter is vary from very low until the high. And in 1996, when I got the funding from International Tropical Timber Organization, I tried to make a species trial in order to know which species owned by Dipterocarpaceae has grew better than other. I did 30 species and planted in 5 concession holder, 5 company with the same design, with the same number of species, and same also time planting. And the result is, among 30 species of Dipterocarp, we found at least 5 fast-growing Meranti. We call it fast-growing Meranti because the increment diameter is very, very fast. Not only 1 centimeter per year, but sometimes 3 centimeter or more than 6 centimeter a year. That means if we follow the cutting cycle, the rooting, cutting cycle of Meranti is about 30 years. That means the increment diameter is 30 by 3 centimeter, 90 centimeter. It's very huge. Based on that research, we already make a recommendation to the Ministry of Forestry and Environment to ask a company that have a program that the rehabilitation forest rehabilitation program using these 5 species, namely Sorea leprosula, Sorea parvifolia, Sorea ceylanica, Sorea johorensis, and Sorea platicados. The other one is not 5, 6. The other one is Sorea macrophylla. It calls in bahasa Tengkawang. Tengkawang is also very familiar, very famous in Malaysia also, because this seed of Tengkawang can be used to be a material for cosmetic. So ladies here very happy because because of Tengkawang seed, they can use the cosmetic for make more pretty. Yeah. Next, yes, this is the map of population in Indonesia. So in 1923, about 270 million inhabitant, stay in several islands, especially the big island in Indonesia, like Sumatra, Java, Kalimantan, and also Papua, Sulawesi. But among those big islands, Java itself have more than 50% of population. So condition of Java island is different with other island, especially in the big island, Papua, for example, or Kalimantan. When we have activity there in Kalimantan or in Papua, sometime during 1 year, very what we call not so often meet each other because the population is still very low. Next. Basic concept of genetic, as I mentioned in the introduction, that there are 3 items of forest genetic that quite similar in meaning. First is forest genetic, is activity that are restricted to genetic study of forest trees. Especially in the genus Tetracarps, there are so many species. If species can be recombinant each other, that means without any objective, that calls forest genetic. But if we want to have a combination between wood in quantitative, in the wood density, for example, and combined with the free from resistance, free from disease, so we have tree with good wood density and free from disease, that calls forestry breeding. But if the forestry breeding can combine between artificial treatment on environment, like fertilizer, like make accelerate optimal growth for water, and then soil, media, and also the other environmental factor that called forestry improvement. And actually forestry improvement is also quite similar all the time with silviculture intensive silviculture. So intensive silviculture has three components. First is genetically improve planting material. The second is environment manipulation. I mean, make environment becoming better. And third is we can control pests and disease. So the combination between three part of element that influence for growth for physiological process that called forestry improvement called intensive silviculture. Next, please. So actually, intensive silviculture is quite similar with if you want to build a good building and strong building. This is analog with if you want to improve, we want to establish a good plantation. So should be structure and foundation should be good. Yeah. For foundation of the house, it's similar with the ecological issues, like silviculture, like physiology, tree physiology, like plant disease, like soil science. These are ecological issues, and structure of building is quite similar with the forest management. So how to harvest that safely, and also how the wood can be processed to be wood construction to be plywood and can be marketed with the high economically value. That's called forest management. So combination between ecological issues and forest management is good plantation, good forest plantation. This is quite analog with if you want to build this building. This building is actually a building for graduate student, yeah, for graduate student located in northern part of our center, building center in not so far from that. Next, please. And tree improvement is actually should be, follow this this flow. We need in situ conservation in the forest, conservation in the natural distribution. So from in situ conservation, we also have to establish ex situ conservation. Ex situ conservation means conservation outside the natural distribution. And from ex situ conservation, we have to do selection in order to make the enough stock, enough preparation for breeding and biotechnology. And then from breeding and biotechnology, we can produce, we can set up the commercial plantation. If we do this flow chart, we will have forests with a productive, efficient, competitive, healthy, and sustained. This is actually our objective to make good forest. Next, please. Scope of tree improvement. There are consists of several items. First is determination of the species or geographic sources within a species that should be used in a given area. So provenance trial or geographic source trial is very important because in based on my experimentation, my research, sometimes different provenance will produce more than 300%. I mean 3 times different. Proven where a certain provenance with other provenance can very, very different result. Second is a determination of mankind and cause of variability with the species, because the variability of species, it sometimes depend on the size of natural distribution, because sometimes also based on the continue or discontinue distribution, yeah, and also because of number of sample used in that experiment. And by the big variation of variability, especially in terms of genetic, we can select, we can choose the best one and can develop to be operational plantation. Third is a packaging of the desired qualities into improve individual such as to develop trees with combination of desired characteristic. So if you want to develop trees, not only grow well, but grow well and also can adapt in many kind of location, it is can be by selected species. Mass production improve individual for reforestation purpose. So if we already find out the best individual from genetic testing, then the best individual can be propagated by vegetatively to use plantings material. And the fifth is develop the maintaining a genetic based population growth through the need of the advanced genes. So the good individual that we realize that the very specific genetic background can be used for advanced generation. So this there are 5 items about the improvement program. Next, please. This is the thick Tectona grandis plus trees. Ladies and gentlemen, if we do tree improvement program, we have to start from selecting plus tree selection. This is very important because we assume that those kind of trees have also good potential of genetic. So we hope that from those like that trees, we can produce seedling, or we can produce material from vegetative, sometimes cutting or grafting, and can be used for material for plantation. Next, please. There are some limitation of forestry improvement for genetic need indirect proof through progeny test. So even we now already know some technological approach like biotechnology, using DNA, using protein and something, but genetic should be proved by progeny test, cannot directly used by DNA or something like that. Second is it needs relatively a long time to do this genetic research. Of course, yes, compared with the crops science. I start to learn forest genetic, to learn tree improvement in 1976 when I start to improve pines mercusii. until now is still continue. But I'm also lucky because somebody said that research on tree improvement cannot be see the result. But I'm lucky because when I planted tree, when I do tree improvement on tick, now I can see the result. Yeah, after 20 years old of improving tick, the result is very is you know it's already a good result we achieve. So need to establish orchard to produce a plenty of seed. Yeah, it is true because the you know flowering and fruiting season of tree is not regularly. Sometimes need 3 or 5 years to have a fruiting season of trees. In the forest, selfing or inbreeding will give a bad impact on maturity. So we have to avoid, we have to, you know, protect seed from selfing, seed from, you know, inbreeding. Sometimes the rule of forestry is inconsistent. Research should be done continuously. This is time we have to patient. If not be patient, sometimes the results cannot be see because we stop in the middle of research. So consistent research is very important. And then formation of basic genetic in the forestries is very limited. That is why the achievement of research in forest genetic in tree improvement is little compared with the other research in the field of forestry, other field of forestry. And the most character in forestries is control by multi-chain. This is quite difficult because if it is controlled by several genes, we not so easy to detect. And it is true because we know that actually research on forestry is simply new, yeah, still new compared with the crops. When our ancestor in the first, like Adam and Hawa, from that time, research on crops already done to make selection, to make to use the best one for generation for next generation. But trees is not like that because it take a long time. So sometimes even in Indonesia, the researcher that has background forest genetic is quite limited because yes, of course, it take a long time. But I'm happy here in the Faculty of Forestry because I already have a junior. So when I have to make retire next year, I will retire because the old is already 70. But I already have 2 junior that will continue our research on forest genetic. Next, please. Advantage of tree improvement, of course, there are some. The improvement of a character can be kept over the number of generations. Even the result is very small, very little, but it can be kept until generation to generation. That's, I think, the most important. The desired character phenotype can be kept and definitely in the form of graft or cutting. So vegetative propagation is really very important. So if we find a good species and have value, economically value, it should be kept through vegetative propagation approach. Because if we only use seed, sometime after we collect seed and germinate, the seed is segregated to be the the father and to be the mother. So of course the quality of seedling is not constant. It will be also variation. But if we use vegetative approach, that means the cutting or the grafting that already we develop will have a good and have the same genetic background with the mother. So mother trees is very important, and this also can be used for human also. So how to select the candidate of wife, candidate of it's very important, because wife is play a role, important role in the development of human being. Genetic variation of forestry is quite broad, so improvement will be very promising. I have experience in collecting seed of Eucalyptus saurophylla from several islands in eastern part of Indonesia, like Flores Island, Bantar, Adonara, Lembata, Blitar Island, even from Timor Island, and also East Timor, that's now becoming the Timor country, Timor-Leste. And we found that from 25 provenances, the result is quite big different. Seed from Remesio in the area of Timor-Leste is grew worse compared with the other island. The best one is come from Blitar Island. It's grew very fast and grew very, nice performance. But Remesio is bad. So in terms of provenance trial, it should be very careful because if we wrong, make a recommendation to use a specific seed from a certain seed sources, it will be very, very dangerous if we have any information about the trial of those selected species. It's very important. The breeder can select the desired character and make recommendation among them to create the new one. So yeah, recommendation is good in order to make new variety, to make new material for planting. Next, please. This is the scheme about how to increase the genetic gain through selection. So usually in the biological population have a normal graph like that. So 25% is bad, about 50% is middle, and 20% also is good performance. So if we collect material from 25 good performance, that means the mean of value is increasing. Yeah. So it is done for several times. We will have very good material for genetic, and of course, even the what we call it, the is very narrow. Genetic is very narrow, but the productivity is high. The other way is, next please. Oh no, it is continued that this is the graph mentioned about result of selection. If you use selection from mother trees and using seed, generative approach compared with if we use a vegetatively approach. The difference is very significant, because if we use seed from generation process, the offspring, the seedling will segregate to be mother and to be the parent. Next, please. Yeah, this is the figure mentioned about the using vegetative propagation. So sometimes we even vegetative propagation, but if the result is not good, result is from average, result is also not so sophisticated. But if we using vegetative approach from clonal test, for example, the result is very good. And for teak, for pines in Indonesia, we already use clonal approach, using clonal approach and establishing the clonal forestry. Next, please. So this is the comparison between genetic variability and compared to the genetic gain, compared to the productivity. Yes, we can increase our value, our productivity of a certain product of forest, but usually the genetic variation is very narrow because limited of the mother trees use. But if we use many mother trees as seed resources, for example, genetic base is very wide. Genetic base is wider, but the productivity is very slow, very small. This is the comparative between variability, genetic variability, and productivity. Next, please. This is scheme that written by Al-Kasri in the introduction of forest genetic with the group of Oregon State University. So of course we start from from the what do you call it, seed sources, and then mixelation, and then establish seed orchard and other through this figure. Please. So, ladies and gentlemen, now I would like to explain about the rule of tree improvement program. Yeah, actually, as I mentioned before, that intensive silviculture is the combination between selected good genetic material with the manipulation environment atau environment manipulation, and also integrated and disease. Yeah. So like we establish a building, we also want to establish it's quite similar with establish plantation. So by this concept, by this intensive silviculture, we can produce plantation with a objective and also the usually the in above is for construction, wood construction, and the below is for pulp, yeah, for pulp and paper. Yeah, next please. This is our experience from improvement activity in natural forests, especially in some Meranti, some Soria. This Soria macrophylla, it's also called tengkawang. The wood is good for wood construction. It's called also Meranti merah, yeah, red Meranti. But the fruit is very useful for tengkawang oil, usually used by people from Malaysia and surrounding Sarawak, Sabah, using the make with the rice. It's called lemak tengkawang. Is if we make rice with the lemak tengkawang, is the taste is very nice. So tree improvement activity, as I mentioned, is always start from selecting good material use. In the middle is a plasteries of Soria macrophylla. Yeah, so from these trees we collect seed and we germinate, and then even in the nursery we also can select the best one to be used for material plantation, operational plantation material, and sometimes also selected good performance of seedling can be established, can use to establish the head orchard and make cutting for clonal forestry. Yeah, and sometimes we face difficulties because the fruit and seed, productivity of tengkawang, or mostly almost all of the diplocat species is irregular. Sometimes 3 until 5 years time to produce seed. Next, please. This is the accelerated optimal growth. Our activity to increase the quality of seedling with the make more to accelerate optimal growth. Yeah, the water, temperature, and longevity of sunrise, and then not so clear from me here. Yeah, but of course the environmental factor can be manipulated to have the seedling is becoming ready for planting. The vigority, the healthy, the size of seedlings also very important. Next, please. Yeah, sometimes because of logging activity in our natural forest, yeah, the condition is becoming, degraded. The cutting cycle usually is already decided to be 30 years period. So after 30 years, they can cut again that availabilities in the forest. But sometimes because many consideration, for example, the condition of root is still good, the condition of bridge is still still good, especially still it can be used for logging activity, and then many equipment is still okay, still well, yeah. So sometimes company also, do legally cutting, legally logging again in that area. That is why the number of available trees is limited, is becoming limited. And if it is happen for several times, that's mean the condition of our forest, natural forest, is becoming bad and bad. After this open access by people, and sometimes the farmer bring any kind of seed, like sometime durian, sometime rambutan, even banana can be planted by farmer in the forest. Finally, it is becoming not forest again, becoming the degraded land, and sometimes this activity because the area becoming the palm oil area. So actually, after it can be doing logging can be done, but it is so make sure that no, the limitation is one period so around 30 years. So, and our program, silviculture intensive or intensive silviculture, is to plan the very fast species. It's called fast growing species in the scheme of like that. So we make two models. First is line planting model, and the second is gap planting model. For line planting model, the distance between trees in the line is 2.5 meter. And the distance between the distance between trees in the line system is 0.5, but between the line is 20 meter. So 1 hectare, that means 20 meter. So there are 5, and 2.5 meter will be 40. So 5 times 40 will be 200 trees per hectare. So our program in line in silviculture, intensive silviculture, using the line planting method, we need 200 trees per hectare. But for gap planting, it's depend on the distance among trees. Sometimes we can use 4 by 6 meter, and sometimes we also can use 8 by 6 meter. And we suppose that after condition is becoming can be harvest, the big equipment can enter in the forest. I mean, like tractor, like dozer can enter in the forest, because the spacing, the distance between tree is quite far. Next, please. This is land preparation when we want to establish the forest. So the distance, I mean the what we call it, area that's free from trees, free from shadow. I mean, this sunrise should be easily to get the land, and we make sure that land have enough sunrise. In order to that, we need the space is about 3 until 5 meter. So from the beginning, if we know that there are some trees close to that line to that area, it should be cut from the beginning in order to not becoming a shadow for this line. Next, please. This is some performance of species trial around 20 until 30 species of deep cups already tested, and there are some species that we call that becoming a good candidate for next generation, like Platylados, Jauriensis, Leprosula, Macrophylla, and others. Next is, yes, at first I also don't believe that Meranti is very easy to be planted. Meranti is actually difficult to develop, but after the success in establishing the plantation, actually the result is very, I'm very happy because we can develop Meranti. So by this experience, we believe that our natural forest can be maintained safely, because we not only concern on very slow, I mean, the increment on increasing the diameter, increment diameter, but we believe using the fast growing Meranti, fast growing Surya, they will be have a good plantation of Surya. This is in several company like PT Erna, PT SPK is Sari Bumi Kusuma. Then both of the companies located in Central Kalimantan, but also we found several other company in East Kalimantan, in West Kalimantan. So right now, the number of company that involved in this silviculture, intensive silviculture activity is, I think, more than 100 companies. Yeah, and all those companies is recorded by the Ministry of Forestry and Environment. Next, please. Ladies and gentlemen, it is quite clear if we compare with the planting activity. In the left side, this TPTE means the selective and planting silvicultural system. So in Indonesia, there are silvicultural system. That means selective cutting and planting, and yeah, it is quite often implemented in the natural forest. And in the middle is line planting that using, sealing, means intensive silviculture method using the line planting pattern. So you will see that the forest is still covered well, and in that forest there are several Meranti that grew in line, that the performance is very, very good. And in the right side, there's the Surya Macrophylla is that you know that's just 8 years old. The diameter is the big tree is quite similar with my body. That's I stay under the tree. It's just 8 years old. It's very fast, grew very fast. And if we you know observe by drone, you can see that the compartment is a nice performance. So in the lines, yeah, lines, but actually lines in the cap area. Next, please. This is the real result. Nothing is 12 years of 15 years old of Meranti. Actually, this year we asked to the government to try harvest this as an example. We would like to know actually how many cubic meter will you know found from this forest. Not so large, but in this company, it has you know regulation that will cut the forest. The size is 2,000 until 2,500 a year. Because now in this company already have plantation about 50 million hectare. 50 million hectare. 50,000 hectares. So will be cut, you know, annually 2.5 thousand hectare until 2.5 thousand hectare. So I have a you know write a letter to Ministry of Forestry to ask the permission to see the result of our plantation. It is can be continue or not, for example, like that. But unfortunately, maybe because of the this time is election year, so it's quite difficult to you know maybe it's not so. The ministry is very busy, and yeah, so maybe next year I will try to ask again. Next, please. Ladies and gentlemen, now we continue with the tree improvement on pines merkusii. Merkusii is a native species in Indonesia, mostly distributed in Sumatra. Yeah, this from you know Vietnam and jumping to Sumatra without stay in Malaysia. So Sumatra and then fly again in the Philippines. So this is the performance of natural distribution in Aceh, in Tapanuli and Kerinci Province. I've been there in 1979 and also in 1984. So at the time, the condition is still good. I don't know now. I hope that it's still good. Aceh population is the distribution is very wide, and also the variation, genetic variation is also very high. The most dangerous one in terms of size is Kerinci population. It's the southern part of natural distribution of pines merkusii. And Tapanuli is still okay, even not you know not concentrate in you know in specific area. We have to collect, we have to, because start from this year, we also have to program to make exit to calculation of those three population of pines. I would like to establish in to Balik in North Sumatra, Aceh population, Kerinci population, and also Tapanuli population. I'm lucky because it will be funded by timber asset company that also invest in in preparing material for pulp and paper. You know that the pulp industry is usually consists of a long fiber and short fiber. The long fiber is mostly come from pines, and now the big company of pulp and paper imported pines from New Zealand. That is why we want to, if we can use mercury as a raw material for pulp and paper, maybe we can save our money. If not, we will depend on New Zealand. Always depend on New Zealand. Next, please. This is the scheme of three improvement program. So we use this population, natural forest or plantation, and selected plus trees, and we also develop seed for regenerative approach, and we use cutting. We use brands of vegetative material for cutting or crafting. So both we implement both of the method to prepare, to select, to prepare the good material for operational plantation. Next, please. So start in 1976. For the first time I start the tree improvement. We start from plus trees. We try to select the best one among the crook one. Yeah, even the stem form is very crook, but in that stand, that crook stand, we still find a good one. So we select the good one, we collect seed, and we make nursery separate one by one. I mean, separate among selected plus trees. Next, please. Then do progeny test. After racking time, we do racking. From 5 becoming only 1 trees. So we avoid inbreeding. And finally, we will establish a good seed orchard like in the picture. This seed orchard is located in Jember in East Java, in Baturaden in Central Java, and in West Java is in Sumedang in Cijambu. Now, this orchard produce seed for operational plantation, forest owned by state-owned company, Perum Brutani in Java, especially. So those people is the trainees want to see how to establish the, for example, how to manage the plantation, how to harvest the seed and others. Next, please. So it's a very nice stand from the crook becoming very strike stand performance. So from 1977 until 1997, the period of establishment. And from 1997, we changed the objective angle from, the objective is to establish the strike and grow very fast pines become produce the good resin production from character that can be used for pulp and paper becoming the character that can use for cosmetic. Next, please. This is a method that we try to, tap the resin from pine tree. Next, please. For the wood, for resin production, we do the same method. Same method with the pine, seed orchard that we established for growth rate and slackness. So we also select very huge number of clusters. When we establish, growth rate and slackness character, we use 1,000 clusters, but now we try using 1,025. 1,250 clusters. But I think now it's not all can be used for mother trees of orchard. Next, please. Next, please. Yeah. So quite similar with the establishment of this strategy of breeding in teak. This also used for pines. Yeah, next please. This is the type of resin. We use bore, and with the diameter is 120 to 2 centimeter. With the use until the xylem part, not in phloem but xylem part, because the location of resin in pines is not like rubber. Rubber is located in the outside in the phloem, but pines is located in the xylem part of the wood. So this we try this method in order to have the premium quality of resin. The premium quality of resin has very expensive value. So and also very relatively clean. So can be can be shell and will have a very lot of money, for example. Next, please. This is the orchard, seed orchard, but this not related to the growth rate and slackness. This is the orchard related to the resin production. So we already have this orchard located in 2 locations in East Java and 1 location in Central Java and one location also in Java. So there are two approaches to have a good material for resin from seed orchard and also from vegetative propagation using grafting. Next, please. This is the method how to make a vegetatively material. So just you know, make you know, take a part of the you know, skin of young branch and then cover by sphagnum, and then after two months, for example, 2 months, yeah, can be cut and planting in the forest. Next, please. This is the scheme. So by activity, I mean by improvement of pines, we can increase the productivity from 10 gram becoming 100 gram per 3 days tapping period. Every 3 days tapping period, we will have more than 100 gram instead of 10 gram before. So this is activity. As now the very important result is rosin ester, and this usually can be used for root marker. So if our government establish the highway and make a sign on the road, so they use rosin ester to be marker of route. Next, please. This is just strategy for the development of this, you know, pines. Next. Yeah, it is the last discussion. I would like to talk about the teak plantation in Java. This actually is good, but we still need the homogeneous of the plantation, because sometimes even the age is the same, but the size of the trees in you know, in stand is not similar. Next, please. So yeah, like in Dipterocarpaceae, like in pine, we also start with the plastris of teak. So we use plastris to objective. First is establish the seed orchard, and the second is establish clone seedling seed orchard and clonal seed orchard. Yeah, next please. So from plastris, and then we establish head orchard and make preparation for cuttings. Next, please. This is the method to prepare cutting by multiplication of your brains, yeah. And also we use the Ruton F and also other what we call it, make a growth regulation, yeah, like IPA and others. So when the sprouting have two of leaf, and we cut in the a part of the what do you call it? Yeah, like this picture, like picture, and make cutting. But before we transfer to the polybag, we put in that Ruton F or IPA with a specific concentration. Next, please. This is the clone, promising, very promising clone. It's clone number 110 and number 97. And now clone, those two clone is already planted in several location, and I heard for the information that now it's become, you know, it's very huge, 120,000 hectares already. But I'm really very worried because if only two clone, I call it my miracle clone, because this clone can be planted everywhere and produce good plantation. So really, you know, it's a very, you know, miracle clone. But I'm worried because if only two clone, it will be very dangerous, especially for disease and yes. And from you know, last time we already decide that we will add until 15 or 25 clone in order to make genetic is still broad, not too narrow. So I hope by this maybe the you know, we will not so worry about that. Next, please. This is scheme that I try to make a picture from selection, plastic selection until the establishment of clonal, you know, plantation, clonal plantation, and also make the demonstration plot or make a combination between integrated forestry farming system. So using a planting crop in between tick. We hope then that in the period of harvesting teak, 20 years, for example, we will get you know, a big volume of teak, but annually from planting teak, we already, you know, we will harvest many crops like corn, like rice, like yeah, other crops, maybe chili and others. Next, please. This is the clonal test of teak located in at least 3 locations in Central Java, in East Java, and West Java. And by this clonal test, we will, you know, we will have a good candidate clone for operational plantation. Next, please. This is the stands produced by clones. Clonal plantation is located in Wanagama, in our forest in certain part of campus. I hope you will visit there also. And the other is clonal plantation located in East Java in Nganjuk district. So the performance is very good. And also, of course, the product productivity. I mean, the wood production is also very high. Next, please. This also activity related to the wood density and other activity related to chemists and also physics character. So by racking activity, we can produce more faster, trees, and also will in fact the impact on wood density. Next, please. Ladies and gentlemen, you know that this is the 20 years old of teak that I planted in one district in Central Java. So I have tried to really cut this tree in order to know the volume, to know the wood density, to know the other character of teak. And I'm surprised because this from 100, around 150 trees produce about 300 cubic meter. So in the beginning, when we still use a local seed source, the production of teak in hectares is only 60 until 80 cubic meter per hectare. But using this good quality of clone, we can produce around 300 until 400 cubic meter per hectare. So I think it's very, very promising. So, a job in terms of supporting Indonesia for preparing raw material of wood construction, especially for teak. Next, please. This also related to the land coverage. And so when we start doing research through plot filtration in 2012 until 2021, so the changing of forest cover is quite significant. And reality the plantation you can see in the picture. So very good, very good performance, and also seem very healthy and other good character. Next, please. This is the colonial orchard also, and the other one in the upper side is a combination between crops and teak plantation. Next. Yeah, I think it's enough my presentation. If everybody have a question and want to share the idea, I'm very happy to answer. And thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you for your very insightful presentation and the long stories of the legacy for not only from Prof. Naim, but also from our faculty for Indonesian Forest. And we know silin is one of solution for economical and ecological issues for Indonesian forestry. So I hope everyone have attention for the Q&A time. We have 50 minutes for everyone online who have an question can join. So anyone have a question? Okay, okay. Okay, please, Miss and Mr. So first, ladies first, please. Sorry, please state your name and your affiliation. Thank you.
Assalamualaikum, Dr. Naim. I am Nurul Shakila from University Malaysia Sabah, Malaysia. Thank you so much for the very informative and interesting lecture. I have like a few questions, but this one actually for more about forest things, restoration. So I have a friends in my university. So she wants to produce like a mass volume of seedlings for restoration purposes. So one of her objective is to see which method is have a better survival rate for the seedling. So she took seeds from the mother tree, and also she do a stem cutting to produce the seedling. So yesterday also I asked. So yesterday we went to Wanagama Forest. So we also visited the teak plantation there, and Dr. Yeni also explained to me that vegetative propagation have genetically vegetative propagation have a better could produce a better seedling compared to the seed through seed germination. But I wonder and I admit plantation wise, it is important for us to produce a very good seedling. But I wonder, in your opinion, for restoration purposes, is it like worth it if we produce the seedling through vegetative propagation that has a better quality, that follows more her mother quality, or it is okay for us to just produce the seed through seedling through seed germination? But yeah, firstly, I also want to know which method has better survival rate. And then and then second question is does the for the stem cutting, because just now you you have showed you do a stem cutting for the stick plantation, right? So I wonder, does the so when we sample, when we do the stem cutting sampling, does the position of the stem, where we cut the stem, like upper of the crown or middle or the lower part of the crown, could affect the growth rate of the seedling? Thank you.
Okay, thank you. Please, Prof. Naim, for the answer the question.
I'd like to answer the second question first. When we use a cutting, actually it's depend on species. Like eucalypts, like acacia, like diptercarp species, is actually they will be or they will need the rejuvenile period. So after those kind of species, diptercarps or eucalypts or acacia, having 4 years old, even it is located in above, in middle, low branches, low, the structure of trees is not so good, is bad. So be should be changed the material for head orchard. But for teak, it is quite different because when I start to make establish head orchard in 1998, because we start to 1997, but establish orchard and produce of 1998 or 1997. So of course it's already 20 years old, yeah, more than 20 years. The condition of that orchard until now is still good for produce the cutting. That's, I think, only teak that have ability like that. But the other, like cassia, like deep capacity, for example, on every 4 years, 3 years, 4 years must be renewable with the planted new one to be the head orchard. This is the answer on the second question. For the first question is the difference effect if using seed or using vegetative. Actually, the vegetative propagation has the same genetic background of the mother. So if we use seedling and then we cut the seedling and try to produce cutting. If we cut cutting and planting in the poly bag and transfer to the field, is really quite similar with the orchard. The parent. The parent. Quite similar. Genetically is the same. But if we use generative, because when before we collect seed, when mother trees is produce flower, female flower or male flower, so female flower usually fertilized by the other male from other result, other trees. That means male and female will produce the gamete and produce the progeny. So if we collect seed from that kind of phenomena, that means after we plant in the field, the genetic structure will separate to be father and mother. So of course, in terms of quantitative character, will lowers than the parent. So it should be, first we have to find a good material for head orchard, and then we produce cutting from that. Yeah, thank you.
So the next one, microphone, please. Please state your name and your affiliation.
Good afternoon, Prof. Doctor. My name is Alex and I'm from Malaysia, University Malaysia Sabah. So I have a question about a bit confused, but thank you for the presentation. It was a wonderful one. And just now you have depicted a figure regarding ceiling line planting technique, specifically in locked over area or degraded area. And the spacing for each trees to be planted was 2.5 meters by 17 to 20 meters, something like that. And I am aware of the large gap, lebar antara jalurnya, in which, as you said, it facilitates as a shelter for the predator habitat. So in a degraded clear-cut environment, when the trees were planted in early stages, is large gap filled and planted with any other plantations or trees for the habitat, or just left them blank or as it is until the perennial plants or trees automatically develop on its own? Thank you.
Okay, thank you for your question. That actually for silene, intensive silviculture technique, there are I mentioned there are two methods, two approaches. First is using line planting method. Second is cap planting method. And again, intensive silviculture is not system, but this just method, just technique, or deep capacity, making plantation of deep capacity. Then we know that by the research, we know that actually even Meranti, some Meranti is, need the open area, but the other Meranti is sometimes also still need the shadow. For line planting, we start with actually log over area. After planting, after log over area, there are some area that's maybe because of effect of logging, that's seem to be not so dense. That's why the location like that, we make a preparation. We cut the other trees with the distance 3 until 5 meters along the line. And between line planting 1 and line planting 2, there's still secondary forest. Yeah, secondary because we start from secondary forest, but in order to increase the potency for natural forest, we need a plantation. They need certain trees that we guarantee to grow there. That's why I think in term of success in the field, we saw that yes, especially if we use fast growing Meranti. That's but for cap planting, we actually there is a consideration, but the size of open area that can be planted by cap planting method is limited until only 2 hectares. Why 2 hectares? Because if more than 2 hectares, 3, 4, 5 hectares, the condition of humidity, even above or below ground, will be changed because the environmental is quite large. But if only around 2 hectares, the humidity can be maintained, can be kept by stand that grew in between that gap area. So that is why we guarantee that even in open area, but it's not more than 2 hectares, that's still okay. Yeah.
Thank you for Prof. Naim for the answer of the question. I think because we have a limit time, so from our first participants can note the question and maybe can ask to Prof. Naim directly from the emails or others. So before we close, maybe have one question. So we start. Okay. Okay. I will briefly some summary from our discussion today. We now already study about the tree improvement approach and show us how to form the basic concept of genetic to implementation of the forest, especially in Indonesia, with the ceiling concept based on the genetic tree improvement approach. So back to my question. We study a lot of the some species, but my question is how to maintain the genetic gain for the result from the tree genetic and tree selection.
Thank you for your question. To maintain, in order to maintain genetic gain, of course, genetic gain is related to the number of plant material used in that program. For example, like teak, we already select 600 plus trees all over Indonesia. But we only use very small because only 2 selected based on the good performance. But I mentioned to you that we still need, to try to add until 15 or 25. But 600 selected trees now is still kept in the research center in Cepu, for example. Why? Because sometimes maybe we still need additional activity related to as I mentioned in the preparation and the lecture that sometimes we want to make a recombination between a certain character, growth very good and resistant to the disease, for example. Growth very nice, but can adapt it in the very bad area. That's also a character that we want. So if we don't have the resource, the conservation of the genetic material will be very dangerous. So actually, conservation is just for conservation. Conservation should be implemented. That means the 600 plus trees must be conserved. But in terms of benefit, we can select some of them and propagate and planted in very operational plantation. That's the concept of a combination between utilization, that means gain, and conservation, that means genetic material. So should be still needed to the next program. I think that's it.
Thank you, Prof. Im. So the combination from the others material is very important to maintain the conservation is a solution for the opportunity the next futures approach. So I think today is thank you for your attention. Thank you for discussion and thank you for your comment and the question also. So thank you for the lecture from the Prof. Naim. So I think it's a very big legacy for forestry and our study. So before we close, please give a big applause for our lecturers today. So please, the committee, I think will be back.
Okay, thank you so much. We would like to be really thankful and appreciate to having you, Professor Naim, and also Dr. Nasty, to be our third of today's keynote speakers and also moderator for this session. Also, for all the participants, thank you for who has engaged in an interactive discussion and understood the topic as well. Before we really gonna end this session for today, ladies and gentlemen, all of the participants in this room and also in the Zoom meeting, kindly rise from your seat and take a photos together in front of here as our appreciation to Professor Naim. And please, for the in charge, please prepare the memento to give to Professor Naim. Okay, please, ladies and gentlemen, rise from your seat, and we have to take a photo here as our appreciation to Professor Naim.
Let's go, guys. Move on. Photo session.
Okay, so this is our appreciation from faculty. Okay, so this is our appreciation from Faculty of Forestry to Professor Naim as our third speakers today. Okay, please everyone give warm applause. And continued by photo session. Okay, that's all. Please everyone take your seat back. Okay, so before we really end this session for today, after this we will gonna have a coffee break session and we'll be back here at 3:50 p.m. Then please everyone still hydrate. So please take some water to keep your hydrate and ready to join game session. Okay, so we will back here at 3:15 p.m. Thank you.
15 p.m. Yeah. Once together here back. So make sure to bring your bottle water and stay dehydrated. Azik Rosdi.
Recording stopped.
Okay, please, everyone, pay your attention, have your seat back, because we will gonna proceed to the game session at 3:16. Okay, good afternoon, all of the participants in this room and also in the Zoom meeting. Welcome back again at the last session of this day's lecture session. Before we gonna really end of this day session, we are going to end our agenda for today with the landscape games. And these games will be conducted by Mr. Wahyu Wardana. So because we only have limit time, without further ado, Mr. Wahyu Wardana, please proceed the stage. Please give a warm applause.
Okay. Good afternoon, everybody. Today we are no lecture today, but you all will play in Klim. We will divide it into some smaller group. Then you'll play in game. But first, before we are playing the game, that I would like to give a short story about this background about the game and then how you can play later on. Please, could you share? Yeah. Okay. Actually, it was, well, this is old-fashioned game, but no computer apps. We think that we can
Recording in progress.
we can develop this kind of game earlier. We developed in this game is 2007. At that time, we have we call it LBF project that time, and then this is the ideas coming from Heri Purnomo. Right now is a professor at IPB, and then we are part of that team at that time. So I was mentioned in that game as part of the contributor who developing this game. So this game, the idea of this game is we can play to measure the dynamic of the land competition, see about the land management, policy measure, and the sustainability of landscape. So next. Okay. This because the theme of this this course is about the managing landscape. So one thing about the managing landscape is there are various actors and as well as the consequences about it will influence the land cover as well. So this is one of the idea. So that's why we need the better understanding about the behavior of the actor The second thing is how they can react with the set of policy rules. And then there is also sometimes we have to be, when the managing the landscape, there is a trade-off. So you cannot choose both, but you have to choose one. And then this is a tools. The game is, the idea is a part of the tool to understanding the complexity, for facilitating, for influencing, persuade the idea, influence the thinking, and then we can influence the behavior to change. Next. Okay, this game developed by, I've already told you, by Professor Ir Mohammad Na. At that time, we funded by LPF. It's about the land competition, maximizing benefit, and then the sustainability. And then you can learn how the strategy of each player later on. And then the aim is we have a landscape. I will explain later on. But the group of player, we will have a kind of the investor. The player can be corporate, and we have bankers, we have markets, and then also we have a government. It's all about explicit, implicit, and virtual reality. Next. So this is the idea. When we see this kind of the picture of the landscape, and then we try to make meaning, involving the process with all of the actors inside. And then we develop a kind of the spatial mosaic like this, the setting, and then we convert the real world game, process into the, like this one is player, and then from this landscape, next. So this is the rule, the concept. We have the mosaic land. The mosaic land consists like the agriculture part, urban, and so on. And then you can do something in there. And we have a forest age. You can do agriculture expansion. You can convert into another thing. And then this is the rule. And then we have the forest core. Then you will have a very much restricted activity or investment, this kind of this landscape. So this is the concept. And then we have the governance challenge, how government can manage. So any one of you who play as a government should see those kind of thing. Next. So this is the condition like this. This is the money, the cost, and then the return, and then the hypothec, and then the value asset. So you can sell later on. You can do the hypothec. You can maybe we can add some of the rule, but it's up to you later on. You are more the one who play as a government has an authority to do that. Even renting, to rent. So this is the condition. And then, so recommended to play at least, you need at least 4 hours. You will divide it as a group. Don't worry, you will enjoy this, because like a Monopoly, you still remember Monopoly? Maybe you understand how to play Monopoly. So this game is the same as when you play a Monopoly. And then starting, every game start with every player will get 200 bankers, and then you will do randomly using the ditch, and then you throw, and you get the number, and then you put as a initial starting, and then after that you will run the ditch again. Then you kill the running, and then you get which cell, and then based on the cell you can choose, you can play, you can decide what kind of the investment you would like to invest. Only some certain cell you will have only for water, mining, as well as you got unlucky, you got lost maybe because of the disaster, because of the unlucky situation thing like in real world. Yeah, you get lost something. Yeah, and then later on we will have a discussion. First, we can ask the strategy. You can ask, you can see what is the landscape condition after we finish the play, and then the effectiveness of the set of the rule issued by the government later on, and then we will discuss more further after this when you have finished the game. So the game is, we have for the test, and you can throw up. So I don't know how many we are. 27. So at least we need per group is at least 7 to 8. So you can play by a smaller one. So then we can have more those things as well as the money. I need maybe Paiha, have you will form your small group or will be arranged by Paiha? Okay, so 27 divided by maybe 4. Oh, okay. So maybe 5, maybe more. Just count it. How many we can play? We can play as group. The rest of the, if you are not either government, bankers, and the markets, some of you you can play as an observer. You can see, you can record the process, and then you will see what happened, the behavior of the actor, even the government, either the market as well. So the job of the market is to decide the price of the commodity per each of cycle. So it's up to market. As a market, you can play that this commodity rise up, and then some commodity, the price is going down. Then you will see the behavior of the player, as well as the banker. For the player, you can ask the bank rent, and also you can collaborate with the player as well, as a group. Maybe I mean as your ally. So please, if you have any questions, comments, or you may first play first. At the beginning, maybe slower, but after that, faster. And then maybe you and each of the player will be competing each other. Maybe you will kill each other later on, because you will clear their business as well. You'll take over the business of the player as well. So okay, yeah. No. This is the landscape. So like this, and then ada dunya teach. It's of this. There's a teach. At least. Yes, 3 or 2. Should be 3. Should be 3 as well. But 2 is okay. Okay, so the teach is like this. It's 3, and then this is the landscape. See. I mean, you can go, and then at the initial thing, you just throw it's like this, And then, okay, you get number 5. So it means you are starting, put your position at number 5 somewhere here. Number 5, so it's here. So this is the beginning. So this is the actor, represent the actor, different color, black, blue, and red. And one of the thing should be another different color. White, okay. So we have 4 players like this. So like the first one, maybe this is the first flyer is blue one, but initial you cannot invest anything later on. Yeah. Then after something like this, and then the other is this one, and maybe this one, and then you'll start throw the deeds like this. Okay, how many? So 1, 2, 3, 4, 5, 6, 7, 7, 8. So what this is? No, this. Which one? Forest Edge. Forest Edge, right? And then you can, I mean, right now is the government should decide. Yeah, I mean, government give a rule. Okay, it's allowed to convert it. It's only for the business of forestry sector. So it's up to the government. Maybe sometimes government allow to
you.